Okay, so guys, we've started to look at the coordinate geometry of the circle. Now, we had been working on circle theorems before that, but we are now looking at how do we represent the circle as an equation. And we looked at in class today a number of circles. So we started out by picking a circle with the center 0, 0 and a radius of, say, 2. So I picked that circle there. And what we can see here is that the equation of that circle is x squared plus y squared is equal to 4. If I was to do another circle with a centre of 0, 0, and let's say this time I'm going to go for a radius of 6, what we would see is that that circle here, so let me change the colour so we can see that that circle there is x squared plus y squared is equal to 36. And I'll do one more just so we can see what we saw in class today, which was if I make that a radius of 10, and I change the colour for us here so we can see it a bit better, that blue circle has an equation of x squared plus y squared is equal to 100. So we discussed this and I asked you to talk to the people around you and come up with a generalised formula for this, and you notice straight away that the equation was always equal to the radius squared. Always. So that's the first thing we noticed. Then to figure out what does this x squared plus y squared and how does that come into it and what other things come into play, we started to make some other circles that didn't have a centre of 0, 0. So what we're going to do there is we're going to have a look at then some circles that don't have a centre of 0, 0. So I'm just going to remove these points here for us and get rid of these so they're gone. And I'm going to now create circles that do not have a circle centre of 0, 0. So I'm going to go to this point here, which is 2, 2, and I'm going to give it a radius of, we'll say 2. And here we have the equation of that circle. So we have x minus 2 squared plus y minus 2 squared. Let's try another one. I'm going to create another circle. This time I'm going to go for minus 4, 4, and I'm going to give that a radius of just 2 as well. So I click that there. So we know that it's equal to the radius squared. But what we have in this case is we have x plus 4 squared, y minus 4 squared. And we looked at that and we wrote down the equations for a number of circles today. And we started to see that actually there's two things that decide what the equation of a circle is going to be, and that is the centre and the radius. So the centre comes into play as a result of where it is. Into the formula we have here, because I was at minus 4, my formula became x plus 4, y minus 4. And we said we came up with a general formula in class for that. So I'm just going to write that out for us in here, what exactly we are observing. So what we have is we had a centre there of minus 4, and let's just say for argument's sake we had a radius of 4. So we have a circle that had centre of minus 4, and a radius of 4. And we said the formula that would give us that circle was x plus 4 squared plus y plus 4 squared is equal to 16. If I had a circle that was 2, 2 and had a radius of 2, we saw that that formula was x minus 2 squared plus y minus 2 squared is equal to the radius squared, which is 4. If I did another one that was 1 minus 2, for example, and had a radius of 3, what we would see is that actually that goes to x minus 1 squared plus y plus 2 squared. And all of that is equal to the radius squared, which is 9. And we started to see that there was a general pattern that we had here. And he said that if we were to give the centre of hk, so just picking these two arbitrary letters, doesn't matter what they are, I'm picking hk, and I was to pick a radius, and we're going to leave it as the letter r for now to represent the radius. What I would get here is x minus h squared plus y minus k squared. and that is equal to r squared. So that's what we're looking at. That's the general formula for our circle there. So really important formula. And we said that this formula was given to us as a result of other mathematicians doing hundreds of circles and drawing those out and getting the equation of each circle and presenting us with this generalized formula that could represent any circle with any radius and any center. So that's what we started to look at today. So some questions we were working on then. So nice and straightforward. One of the first questions we looked at was, how would we deal with a center of 2, 2 and a radius of 5. So what we would be doing there is we would have our general formula, which is in your log tables. The general formula is x minus h squared, y minus k squared is equal to r squared. So hk is the center, so that's my h. My k is going to be my 2 in this case, and my r is going to be my radius, which we have here as well, or r squared, like that. So then what we do is we fill into the formula, which is a generalized equation of any line out there now, or any circle out there. Now we're looking at a specific example where the center is 2. So we're going to look at that. So we've got x minus 2 squared plus y minus k. So y minus 2 squared is equal to 5 squared, which is 25, like that. So that's all that is. Using that formula, it's in the log tables. It's on the same pages as the equation of the line. In or around there, you'll find it. So for any equation of a circle, we need two things. You need the center and you need the radius. Now, obviously, it's going to get a little bit trickier than that. So this is where we left off today. So we were looking at, what about if we know the center and we know a point on the circle, but we don't know the radius? How would we get the equation of the circle there? So we know that the center of that circle is going to be at the point 2 minus 1, which contains the point 5, 4. So the point 5, 4 would be higher up and much further over. So somewhere over here, just quickly sketch it. It doesn't have to be very accurate. It's just to show us a model that we can use to conceptualize what's happening here. So we have this center and we have that point, but we don't have the radius. Now the definition of the radius is talking about the center of the circle out to a point on the outer edge of that circle. That is our radius. So if we are able to work out the distance between our center, which is 2 minus 1, and our point, which is 5, 4, if we can do that, that distance represents the radius by definition. So we said what we're actually looking at right here is the length of a line segment, because a line segment is a line that connects 2 points. So there we go. And that is in the log tables, and it is going to be x2 minus x1 squared plus y2 minus y1 squared. That's our formula for that. Where do those things come from? Well, that's my x1, so I'm going to say x1 there. My y1 is going to be from that bracket as well, so there's my y1. So I'm going to have that. I'm going to have 5 here, which is my x2, and then I'm going to have 4, which is going to be my y2. Okay, and all we're going to do then is sub into that, and what we're going to be able to find out of that is actually our radius, because it's going to give us the distance between the center and a point on the circle. So we're going to figure that out. So it's going to be x2, which is 5, minus x1, which is 2, plus y2, which is going to be 4, minus 1. So we just be careful with that one. So minus 1, and I put that in a bracket for myself to make sure I don't slip up with the sign there. And then what we have is we're going to have 5 minus 2 is 3 squared. And then 4 minus 1, that's going to be plus 5 squared. So I'm going to get the square root of 9 plus 25, which is going to be root 34 in this case. So that's the distance of the line segment there. But we said that that distance there was going to give us the radius, because it was the distance between the centre and a point on the circle. Okay, so now I have my radius. What I need to do next then is I'm going to have my formula. So remember, the formula goes like this: x minus h squared plus y minus k squared is equal to r squared. And where does h and k come from? hk is our centre, always. And r is going to be our radius, which we just found. So we do know what the centre is. We know that the centre of that circle was 2 minus 1. So I'm now going to be able to put in x minus 2 squared plus y minus minus 1 squared is equal to r squared, which is going to be the square root of 34 squared. Tidying that up for ourselves, x minus 2 squared plus y minus 1 becomes a plus squared is equal to 34. And that's what we have there. Now the second part of that question asked us to verify that the point minus 3, 2 belongs to this circle. So if the point minus 3, 2 belongs to this circle, it means that it's on the circle. And just like any other question where they ask you to verify that a point is on the line or verify that a point is on a curve, you're just going to take your point minus 3, 2, and we're going to check that that satisfies the equation. So if I'm able to sub this in for my x and my y values there, so I'm going to be filling that in for my y and my x value, I'm going to sub that in here. If that satisfies the equation, then what we will know is that that point is on the line. So if I get that this is equal to 34, then I'll know. So minus 3 is going to be minus 5. Minus 5 squared plus 2 plus 1 is going to be 3 squared is equal to 34. Then I have 25 plus 9 is equal to 34. Well, is 25 plus 9 equals 34? There we go. 34 is equal to 34, which is a true statement, which means that that point does in fact sit on that circle somewhere. It is one of those points on that circle. So again, anytime you're asked to verify that a point is on a line, always sub it in, and if it satisfies the equation that you're dealing with, then you know it's on the line.